Okay, this is the quick review of common log. So I hope you got your calculator with you. You're going to need it. I've got a graphic there of just a common calculator. Yours will look a little bit differently, but you have to find your logarithm button and it'll say log. Right? And so when you see a problem like the one here, log 340, you have to understand that this is a common log. Notice there's no subscript. That's because the subscript is 10. This is base 10, but we don't show that 10. If I were to convert this, this would be 10 to what power equals 340. And guess what? Your calculator will tell you the answer. All you have to do is punch in the 340 and hit your log button. Some calculators got to hit your log button first, then punch in 340. And here's the answer. This is 2.5315. I like to take my logarithms, my exponents, to 4 decimal places. So 2.5315. You're just simply doing the logarithm or the common log of 340. So again, no matter what the form, all you're doing, we want the common log of 79. Punch in 79, hit your log button, or punch your log button and hit 79. So this is 1. Whoops, sorry about that. Let me grab my pen here. 1.8976 as you round the 4 decimal places. Okay? So log 0.08 equals n, no problem. It's just the common log of 0.08. So again, your log button in 0.08 or 0.08 in your log button. This is actually a negative answer. And I keep doing that, don't I? Okay, so this is negative 0.09691. It's always going to be a negative exponent to get you between 1 and 0. 1 and 0 has to be negative exponents. Okay, this one, z equals log negative 100. Let me change the form and I'll show you what we got. This is 10 to the z power equals negative 100. This is impossible. Your calculator will tell you either a syntax error or a domain error. And the reason is there's no power you can raise 10 to end up being a negative quantity. It's impossible. There's no solution there. No solution. Okay, so that's one way with your calculator. You should be able to go the other way, and that's to do the 10 to the x button. Okay, the inverse of the logarithm. Okay, so it's a problem that's going to look like this. 4.1 equals log x. So again, let me just change it to exponent form so you get a read on what's going on. This is 10 to the 4.1 power equals x. So your 10 to the x button does that. So again, depending upon your calculator, you either punch in the 4.1, then the 10 to the x, or you do the 10 to the x first, and then the 4.1. All right, and you're going to get a big number. This is 12,589.3. 12,589.3. I'm only going to 1 decimal place because I'm not finding the exponent anymore. I'm finding the value, the result. Okay, so this one, again, what is this? This is 10 to the negative 7.9 power. We're going to get a value between 1 and 0. But again, you just punch in the button. So 7.9, a negative 7.9 in my 10 to the x button. And I got, all right, 0. I did it again. I hate when I do that. And so I ended up with 0. Let's see, 1, 2, 3, 4, 5, 6, 7 zeros. And my calculator doesn't round off my last digit. We found that out in class today, so I have 1, 2. It might be a 3 round off, but my calculator only shows me that amount of digits, and mine doesn't round. Nowadays, most calculators will round. Okay, so this last issue, again, 10 to the 0.55 power. All right, so again, I'm expecting a smaller value here, and so 0.55, 10 to the x button, and I got 3.548. Again, it's hard to give a hard, fast rule when rounding these off because you're not finding the exponent. So just whatever seems reasonable, 3.548. Okay? Any result of the exponent less than 1 but greater than 0, it's going to be a number between 1 and 10. any negative exponent is going to give you a number less than 1. Okay? And any exponent bigger than 1 is going to give you a number bigger than 10. Okay? That's the way that's going to work if you understand the relationship between